Aló, aló.
Sí, estoy conectado yo.
Ok, entonces vamos a comenzar. Ya, esto se lo estoy diciendo a los panelistas.
¿De acuerdo?
Ok. So, hello everybody. Good afternoon. My name is Cristóbal Emilfork, and I'm currently a doctoral researcher at the Chilean Antarctic Institute, and I will be facilitating this side event as well as being one of the panelists. As you can probably see, this is mostly a hybrid talk. This event is titled Antarctic Science and Research from the Global South. And it seeks to highlight how, from different angles of science and research, the Chilean Antarctic Institute and partner institutions seek from the southernmost tip of the South to contribute to the development of knowledge about climate change, and from there to contribute to actions that help to the implementation of measures at all levels for mitigation and adaptation. This talk will consist of 4 parts. In the first one, I will present 2 initiatives that expand the traditional way of viewing how we can produce science and knowledge, obviously from the cryosphere. Then Gino, Casassa, Dr. Casassa, current director in the Chilean Antarctic Institute, will present research about Antarctic glaciology. Then these 2 talks will be finally accompanied by the interventions of Dr. Jorge Carrasco, who will share with us some of his research on climate change in Antarctica, and we'll finalize with Dr. Raúl Cordero, who will address climate change impacts on Antarctica. I will start with what I believe to be a fact. We know what is happening with regard to global warming, and the best available science is quite clear about the mitigation measures that must be taken. We also know the importance of not exceeding global warming of 1.5 degrees above pre-industrial levels, or now, as probably you have heard in these talks at the venue at this COP, trying to ensure that the overshoot, if it occurs, which is most likely, is as close to 1.5 and as brief as possible. Last year was the hottest year on record, and this year, according to the information that we all heard this past Monday on Earth Information Day, is on the track to be the 2nd or 3rd hottest year since records began. In another area, we also know that in recent IPCC discussions, there have been talks of the need of greater inclusivity and the writing of these reports, at least in considering the places where research is coming. However, as probably if you have take part of the negotiations, it is still totally unclear what members of the IPCC as well as the negotiations understand with the word inclusivity. Well, considering these 2 previous points in this first part of the presentation, what I would like to do is to take this discussion one step further, and I want to show you 2 initiatives that could contribute in line with the inclusion of new perspectives on research, knowledge and science in the cryosphere to addressing the production of knowledge about climate change from a broader perspective. These, as I was saying, are new perspectives that could perhaps help not only from the exact sciences, but also from social sciences and education to fight against the great difficulty that we see in spaces like these ones for science, and when I say again science, I'm saying also social science, to permeate the political decisions that are being taken with regard to climate change in here. So I would like to start with an educational initiative that has been running in Chile for more than 22 years, called the Feria Escolar Antártica, the Antarctic School Fair. What does this fair involve? Motivating students from school all over Chile to do Antarctic science in pairs, guided by a teacher, high school student, and by this I mean a student from the range of 14 to 18 years old. They can submit a project which is then evaluated by an expert committee that then selects the best 15. So after that selection, those 15 projects with their students obviously and with their teachers travel to Punta Arenas, where the Chilean Antarctic Institute is located, and there they have a very integrative experience with scientific talks, exchanges between them, between the students, and also activities with the citizens of Punta Arenas. As they again in a fair that takes place in a very, very interesting place and very commercial place in the city, they talk about their own projects. So it's a great way of integrating science made by these students or to the common people in the city. So once decided in Punta Arenas, the three winners, they received the prize of participating in the Antarctic School Expedition, which takes place them to Antarctica. They travel to Antarctica, specifically to the base Professor Julio Cordero in King George Island in the Antarctic Peninsula. Just for you to know, and as you can see on the slide, the last winner presented these three projects. The first one is called Analysis of the In Situ Bioremediation Potential of a Psychrophilic Microbial Consortium for the Degradation of Hydrocarbons in Antarctic Marine Ecosystems. The second is called Conciencia, Predictive Modeling with AI and Antarctic Biodiversity as an Ecosystem Sentinel for Climate Change. And finally, the third one is a more historic one, and it's called an interdisciplinary card game for learning about Antarctica since the 19th century. Overall, the result of the Feria Escolar Antártica have proven to be very, very, very successful. As I was saying before, this is the 22nd edition of this fair, and it is a concrete way to bring future generation closer not only to science, but also to the cryosphere. And I point particularly to this because the cryosphere seems so far away from us in general that it is difficult for ordinary people to know what is happening there, especially due to climate change. So for us, it's essential that in a cryospheric country like Chile, we do as much as we can to involve our population in these topics. With this I mean that they could learn about glaciers, ice sheets, sea ice, etc. And obviously it is particularly critical in the context of climate change, in which the cryosphere, apart from being particularly vulnerable to global warming, is real, perhaps the most serious threat to humankind. And obviously, again, this is due mainly to the effect that melting of the polar ice caps could have on sea levels and on the alteration of the planet's climate and ocean systems. So I remember here a side event where Pam Pearson, the executive director of the ICCI, she was a panelist in that panel, and she said what happens in the cryosphere does not stay in the cryosphere. So that is really, really true. I'm going to change the slide now to talk about not another topic, but my topic. And I dwell a little longer in this last sentence because in a way it illustrates one of the motivation behind what I'm studying. As I think that I didn't tell you already that I'm an environmental anthropologist, and my current doctoral research is in the area known as STS. SCS is an acronym for Science and Technology Studies, and what I do is that I don't know if I succeed, to work with glaciologists and study their scientific practices during the different stages of their research. This means to accompany them in their campaigns, their laboratory work, their office work, and even in these spheres, like this, the ones that we are now, where science has an active role in matter of international climate policies. For the ones that don't know, science and technology studies are based on the premise that knowledge is situated. What does it mean that? What does it mean that? That the generation of data, the generation of knowledge on a given subject is in a way mediated by the historical, political, economical, technological, etc. conditions on the context in which precisely that knowledge is produced. In fact, biographical, even friendship networks, nationalities also play a role in the way in which historically knowledge and scientific knowledge has been built. So within my initial research question was, what about climate change? How is this totally disruptive phenomenon impacting the scientific work of glaciology, and how is glaciology, through its work, responding via its practices? It is affecting the practices. Climate change is actually affecting the practices of current glaciologists. Furthermore, given that the Global South is, at least in terms of their population, the most affected region of global warming, how does this premise impact the scientific work of scientists who do science, who conduct science in and from the South? So I would like to invite you, probably you are familiar with this slide. It is taken from Carbon Brief, a UK-based website covering the latest developments in climate science, in climate policy, and in energy policy as well. And this map shows the places where the authors contributing to the IPCC's report on climate science were located. This report is known as the Working Group 1 and was published, if I'm not mistaken, in August 2021. And as you know, this is the first section of the three-part sixth assessment report, AR6 of the IPCC. The second one is based on the impacts on adaptation and vulnerabilities on climate change. And the third installment is on mitigation of climate change. So I quote here, and you will be able to read it with me in the next slide, a post published in March 2023 in Carbon Brief that goes like this. The dominance of the Global North among the citation authorship is stark. While 185 countries are represented across the citations, we estimate that more than 80% of authors are based in the Global North. So it is therefore important to ask ourselves what mechanisms we put in place to balance this scenario. In this sense, building knowledge about climate change from science is not only limited to addressing data gaps in certain regions, for example, where we lack long-term systematic observations. But from my perspective, it is really crucial to ask also about the particular and potentially distinctive role in discussions on climate action policies based, as we know, in the best available sciences. What could be the distinctive contributions of science made from the South and in the South in climate change policies? So now I would like to hand over to Dr. Gino Casassa. I'm going to introduce him. He is a glaciologist, current director of the Chilean Antarctic Institute. He is an associate professor at the University of Magallanes in Punta Arenas, and a corresponding member of the Chilean Academy of Sciences. He will present the current state of the Antarctic sheet and the unprecedented retreat of one glacier in the Antarctic Peninsula. So I hand over to you, Dr. Casassa.
Many thanks, Cristóbal. Is the audio okay? Can you hear me?
Yes.
All right?
Yes, we can hear you perfectly.
Perfect. Thanks again. I'll be showing at first the what is happening to the ice in Antarctica, and then going in particular to a glacier that has shown a very rapid retreat. So if I can have the next one. So Antarctica has a very heterogeneous behavior in terms of the health of the ice. And by health I mean if the ice is growing or shrinking, if it's losing mass or gaining mass. And you can see very large red areas in West Antarctica on the lower left of the image of the map of Antarctica, and also in the Antarctic Peninsula. That is the northernmost portion of the Antarctic continent. And also in a few parts on the right-hand side of the map, which is East Antarctica. But through time, and these are in the graph on the left, you can see the loss of mass of Antarctica over the past, let's say, couple of decades. So this Antarctic continent, which was believed to be very stable, very frozen, now is not. And this is mainly happening in the in the fringes of Antarctica, where the ice meets the coast. And the sea ice is also changing a lot in terms of the Southern Ocean, which is normally frozen in the winter and thaws or melts during the summer to a large extent. But this sea ice is also showing signs, at least over the last 5 years, of melting, which is quite surprising again, because we had the impression, and we had very robust data until at least 20 years ago or so, that Antarctica as a whole was very stable. So let's look at the next slide, please. And Cristóbal has already told us about the warming on Earth and this 1.5 degrees Celsius, but this is the mean warming on Earth, which we do not want to go beyond, above, although we know this was attained last year. It was El Niño year, very warm. But in Antarctica, as is happening as well in the Arctic and in parts of the Northern Hemisphere, the warming has been much larger. And in the Antarctic Peninsula, in practice, it has been at least twice of the warming of the rest of the planet. And John Mercer in 1978, you can imagine, more than 50 years ago, he already made a cautionary voice, and he was really looking into the future when he said that one of the warning signs that a dangerous warming is happening in Antarctica is the breakup of the ice shelves. Ice shelves are these floating ice masses on the ocean, which are an extension of the inland ice. So these are marked as green in this map, and you will see next in the next slide the Larsen's B ice shelf, which collapsed already in a period of 35 days in between February of 2002 and early March of 2002, and we can see this animation where it collapsed in literally thousands of icebergs, an ice shelf that was close to 10,000 years old. So 10,000 years of ice gone in just 1 month. The next one, please. Now, it helps, of course, having water and meltwater, of course, on the surface of these ice shelves that are already melting, not only from above, it means from atmospheric climate warming, but also from below, from this floating ice that floats on the ocean, an ocean that is many times also warming. And water, which is denser than ice, of course, produces these hydrofracture, which extends sometimes all the way to the base. So it breaks from the surface, but also from the base, which is already floating. The next one, please. And that's a typical collapse.
Sorry, go ahead.
That's a typical collapse scenario. And now, what happens, it was a big discussion in the glaciological community some 20 years ago, and there were basically two diverse hypotheses, views on these ice shelves. And on one hand, if an ice shelf would collapse, then nothing would happen to the inland ice. And this ice that was already floating, as I said, these ice shelves then had no effect basically on sea level. And that was a very conservative view. And the other view was that the ice shelves were indeed providing back stress, providing an anchor to the inland ice. So they were very, very important to the dynamics of the inland ice. And in fact, this was proven, the second hypothesis was proven to be true. After the collapse of Larsen B, what was done is measure the velocity of these ice shelves and also the thinning rate. And in fact, you can see in the next slide, and we collaborated with scientists from Chile, but also from NASA in this paper. So in the next slide, we can see that the inner ice streams and glaciers accelerated by nearly 9 times after the collapse of the ice shelf. So if you collapse the ice shelf, the inside the inner glaciers start to accelerate because they have a less restraining force, less resistance, because basically they float, they start to float and terminate on water, which is basically a much less resistance than the ice shelves themselves. So this proved then that the ice shelves were critical to the stability of the inner ice. So next slide, please. And now we go back 20 years later, thanks to colleagues from the University of Colorado in Boulder, and these colleagues, and there's some of the co-authors are not new to the Antarctic, names like Ted Scambles, but also people from France and the UK, and they joined forces to actually analyze the retreat of these glaciers, and Hectoria was the one that had the record, 8.5 times accelerating on the former Larsen B embayment, and this came out as a total surprise that in just 2 months the glacier Hectoria, which was formerly draining or flowing into the Larsen B, retreated by 8 kilometers. And this is at least 10 times larger retreat than has been reported since the Little Ice Age, since about 150 years. So this came out in the world press. The next one, please. You can see the photograph there of Victoria, thanks to a flight that these researchers made on the area. And the next slide, please, shows actually a map of Victoria. Thanks. And in fact, 22 kilometers, if you take this for a year, nearly 25 kilometers within a year, 8 kilometers in 2 months, and also a 6-fold increase in flow speed. And already the speed of the glacier had increased 9-fold in just after the collapse 20 years ago of Larsen B. So now again, another 6-fold increase in the speed. So increase in the speed, incredible retreat, and also, of course, thinning of the glacier due to the acceleration, not only because of the melting conditions, which, of course, involves some thinning, but the major part of the thinning is because of this creep thinning or acceleration that produces the thinning. The same way that we enlarge a chewing gum, as we stretch the chewing gum, of course, it thins. So the ice has a very similar mechanical behavior. The next one, please. Now, part of the thinning of Hectoria and the retreat was on an ice, and you can see there, ice plain, which was already near buoyancy. It is partly floating, so if this breaks up, then retreats, not much is happening with the sea level. That's fine, but it's the inner ice that is really worrying, because this inner ice to the left in the figures is not floating, and it starts to accelerate, breaking into thousands of icebergs, and therefore increasing sea level rise. Now, this in the peninsula is, of course, worrying. It is, of course, important, but the major chunk of ice, the major volume of ice, lies inside in Antarctica, farther south, particularly in the West Antarctic ice sheet, that very red area that you saw on the initial slides. And this is really where the big problem is, because there's about 4 meters of global sea level accumulated as ice, frozen as ice in this part of Antarctica, whereas in the Antarctic Peninsula, there's only a few decimeters, a bit less than a meter. The next slide, please. So this mechanism is, is, let's say, a model of breakup of the ice when it loses the ice shelf, as I repeated, and then you have an ice plain which is partly floating, and that in turn starts to retreat, and then this provides a mechanism for very fast retreat and loss of life. And this can happen, and unfortunately is already happening in the peninsula, but it's also happening for a few huge glaciers, ice streams, in fact, in the Amundsen Sea embayment in West Antarctica. The next, please. So this model actually proves that the ice can respond very rapidly to much rapidly than we thought. And with this, I end this presentation. Thanks very much.
Thank you very much for your presentation, Gino. And without further ado, I give the floor to Dr. Jorge Carrasco. He's a climatologist, professor and research associate at the University of Magallanes, and currently is the president of the Chilean Antarctic National Research Committee. Professor Carrasco, if you are there, the floor is yours. Professor Carrasco, are you there? We are having some technical problems, but okay. I ask you to bear with me the moment. We're trying to reconnect with Dr. Carrasco. I ask you to bear with me the moment. We're trying to reconnect with Dr. Carrasco. I ask you to bear with me the moment. We're trying to reconnect with Dr. Okay, we can see your presentation, Jorge.
Okay, is already everything okay?
Yes, so you can begin whenever you want.
All right. Well, hello everybody. Thank you very much for this opportunity. Today I will talk about Antarctica as the lighthouse of the planet. A region that not only reflects light in a literal physical sense, but also serves as a climate beacon warning us of the changes happening in the Earth's system. Over the next few minutes, I will show you how Antarctica observations and models projections reveal clear signals of change in temperature, precipitations, ice dynamics, and their global consequence. Well, let's start with this familiar figure. Actually, this is from a video that shows how the temperature changed during the last around 130 years. Here just is the last 4 years average from 2018-2022, showing how temperatures have changed during this period. And just here indicated how the temperature has changed in Antarctica. In general, each decade after the 50s showed a steeper upward trend, and globally in 2024, the anomaly surpassed 1.5 degrees Celsius above the pre-industrial levels, as already was indicated, and the Antarctica showed larger warming on average. this continuous rise provides a backdrop for what we observe in Antarctica today. Warming that is no longer abstract, but we can measure. Now let's zoom in the Antarctic Peninsula, one of the fastest warming regions on Earth. And here is just a graph showing the average of the stations located in the northern half of the Antarctica Peninsula. And you can see here an overall warming by the dashed line, black dashed line, but also there is a period of cooling during the 1998 to around 2014, and after that the recovery once again of the warming, and this is just an update, but using only a station, Frey station, indicating during this warming trend during the last 10 years or so. And next, and here what it shows is the behavior of the precipitations also in the northern part of the peninsula, actually data from Frey stations, the annual accumulations, the annual number of precipitation days, and the number of extreme events. We observe a general increase in both frequency and intensity of precipitation events over time. This reflects the warming and moistening of the atmosphere. These changes not only affect surface hydrology, but also influence snowpack stability and glacial mass balance in the region. The impact is already here. Glacier observation tells similar story. Satellite imagery and field measurements reveal that most glaciers along the Antarctic Peninsula have retreated substantially over the last decades. Some show some temporary advance, but the overall trajectory is dominated by retreat and thinning. This directly connects the regional air temperature warming and changes in precipitation regime, making glacier sensitive indicator of broader climate variability. So you can see that overall there has been a decrease in the cryospheric mass in the Antarctic Peninsula, which is also observed in West Antarctica. The last synthesis by Abram et al. Paper just recently published in August this year provide a comprehensive overview of abrupt changes in Antarctica environment. Their work highlights multiple systems, atmosphere, ice sheet, ocean circulation, and ecosystem, showing signs of non-linear transition. In other words, the system is shifting not gradually, but through threshold responses. Here you can see that there has been identified region of susceptibility that has been already observed, and this region in the bottom map you can see that are vulnerable for a rapid change in Antarctica. Also, they indicate that there is another key aspect, which is the Antarctic overturning circulation, the deep branch of the global ocean conveyor that also can be and have a risk. Recent observations and models show a weakening trend of this circulation. The slowdown reduces the renewal of Antarctic bottom water, the cold, dense water mass that sinks and ventilates the global ocean. Where sea ice reduction plays an essential role, and it has been showing a decline at least during the last 10 years in Antarctica. Sea ice formation densified the superficial seawater, triggering bottom water circulation. This has profound implications for ocean heat and carbon storage, and could amplify the pace of global climate change if the deep oceans buffering capacity decline. The consequences are not limited to physical systems. Recent studies show that early fast ice breakout is disrupting emperor penguin breeding. These impacts are compounding through time and space. Colonies that fail 1 year often show reduced recovery in the following years. This example illustrates that Antarctica climate change cascades through ecosystem and affecting species survival. Antarctica is no longer an isolated continent. This statement captures the fundamental truth. Antarctica is dynamically connected to the rest of the planet. Through the atmosphere, changes in Antarctica circulation influence mid-latitude weather and even tropical rainfall. Through the ocean, Antarctica water drives thermocline circulation that regulates heat and carbon globally. Thus, monitoring Antarctica change is not only a matter of polar science, it is a global climate imperative. Projection. This is from the last IPCC report, the MCA6 models that indicate that in general, and this is just projection for this mid-term, or mid-21st century, for the best and the worst scenario, showing that in general, what we expect in the next future is a warming in the area, in Antarctica, mainly in minimum temperature. Warming that would be between 2-3 degrees in the best scenario, but could be 4-5 in the worst scenario. On the other hand, also, simulations indicate that there will be, in general, an increase in precipitations in polar regions, mainly in the summer. And if we think that there will be a warming, there will be also a change in the type of precipitation. There will be more rain during the summer, especially in the northern part of the peninsula. Now, just a small work that I've been doing is validating the projections, but in this case, just using a point, a grid point, close to Freya Station, where we have observations. As you can see here, that in general, in the red curve, you have the observation from Freya Station. So it is the real behavior during the present climate. And the black curve is the average of all the simulations, around 36 simulations. As you can see that even the individual model shows difference with the observation. The average of all of them is very close and reproduce the overall behavior of the observations.
Professor Carrasco, I'm going to ask you if you could be so kind as to wrap up a little bit, because we are lacking some time. So for the next presenter, thank you.
Okay. So this is just the best observation, the best models, just indicating that when you use the best models, the behavior or the projections of the warming in Antarctica is less than the average of all behavior. So just to finish then, what is important is that Antarctica play a crucial role in the global climate system, influence ocean current, atmospheric circulation, and weather patterns. And so it's important that changes in Antarctica must have a direct impact on global sea levels. Melting ice contribute to rising sea levels, threatening coastal community and ecosystem worldwide. Okay, thank you.
Thank you very much, Professor Carrasco. Thank you very much for your presentation. And last but not least, obviously, I leave you with Dr. Raúl Cordero. Dr. Cordero, he currently serves as a coordinating lead author for the upcoming IPCC assessment report, the first chapter, the AR7s, and he's also a member of the UNEP Environmental Effects Assessment Panel, which advises the party of the Montreal Protocol. Since 2024, he has been part of Chile's Advisory Scientific Committee on Climate Change. Over to you, Dr. Cordero.
Yeah, hopefully you can see my slides, right?
Yes, we can.
Okay, thank you very much. So yeah, I'm gonna talk representing my research group, so I'm gonna describe more or less what we are doing. My research group is Antarctica.cl, and yeah, we are working, trying to better understand climate change in Antarctica. So let's talk a little bit about climate change in Antarctica. I would say the most consequential change that we have seen in recent decades in the Antarctic climate is the strengthening of the westerlies. The westerlies are winds blowing from the west, hence the name. And as you can see in this plot, these winds got stronger in recent decades all around the wide continent. So two questions arise, right? Why these winds got stronger? That's the first one. And so what? Causes and consequences. So regarding the causes, I'm going to mention two of them. First, the usual suspect, global warming, and then an old friend, the ozone hole. But for the sake of time, today we will focus only on the consequences. So I'm going to mention two of them, okay? First, basal melting, and second, surface melting. Basal melting was already discussed by Gino in his presentation. But let's try to explain what is the problem. It happens these stronger westerlies, these winds, right, are removing the top sea surface layer, enabling the more frequent upwelling of circumpolar deep water. This deep water happens to be relatively warm. So when it reaches the surface, when reaching the surface, is leading to basal melt. This is melting the ice shells from the base. So it happened also, these stronger winds are favoring the advection of air masses from lower latitudes, often from the tropics. So as you can imagine, if tropical air managed to get to Antarctica, it's gonna lead to surface melting, pounding, eventually hydrofracturing. So I'm gonna show you one example, okay? What you can see here is a storm that hit the Antarctic Peninsula in early February 2022. So the problem with this storm was that it was affecting a long tongue of moisture-rich tropical air. This is what we normally call an atmospheric river. So because it was coming from the tropics, as you can imagine, when this tropical air managed to get to Antarctica, it led to a warming event. So at two research stations, you can see in the slide, Carlini Station on King George Island and Vernadsky, 400 kilometers southward, we saw all-time records in temperature. Also, as you can imagine, having 14 degrees, nearly 14 degrees on King George Island, that's not good for the Antarctic ice. So these satellite images show us the aftermath of that event. The right side picture shows us that immediately after the event, the event basically led to severe surface melting and pounding. Now, what's the problem? These kind of events are occurring more frequently nowadays in Antarctica, and this combination of both basal melting and surface melting are weakening the ice shells. And there is a huge problem because it's leading to accelerated ice flow. You see, in Antarctica, the ice is flowing towards the ocean. That is natural. But the problem is nowadays that ice is flowing faster. And it's flowing faster because the floating part of the ice sheet covering the Antarctic continent, the ice shells, got weaker and thinner because this combination of basal melting and surface melting. So it's interesting because most of the ice that Antarctica is losing because this accelerated ice flow. So basically, Antarctica is discharging into the ocean extra ice, more ice than a few decades ago. So in this plot, also, I think it was shown by Gino and also I think by Jorge, you can see that Antarctica has been losing a lot of ice in recent decades. And over the last 10 years or so, 20 years or so, Antarctica have lost nearly 3 trillion tons of ice. Antarctica is on average losing 150 billion tons of ice. And most of that ice can be attributed to this accelerated ice flow, resulting at the very end from the stronger winds surrounding Antarctica. So my first message to you today is the ice losses in Antarctica are driven by atmospheric anomalies. You see? So it's very interesting that something that is affecting the cryosphere is actually is related to what is happening in the atmosphere. But I have another message to you today. My second message is, if you are really interested in learning about what is happening in Antarctica, if you are just like us, interested in the effects of climate change in Antarctica, the Antarctic Peninsula is the place to go. Not only because the Chilean Antarctic Institute can provide you support for conducting your research in that region, but also I'm going to give you three additional reasons for favoring the Antarctic Peninsula if you decided to become just like us an Antarctic researcher. So the first one is the Antarctic Peninsula is part of West Antarctica, and West Antarctica is the region where most of the ice losses are occurring. Second reason was also mentioned by Jorge. The Antarctic Peninsula is the region that has warmed the most in the whole southern hemisphere. There is no other region in the southern hemisphere that is warming that fast. It's extremely fast what is occurring, the warming that is occurring in the Antarctic Peninsula. And the third reason is that the Antarctic Peninsula is the region where crazy things are occurring. This picture, especially the right side picture, is showing you the aftermath of the landfall of an atmospheric river that hit the Antarctic Peninsula nearly 2 years ago in winter 2023. So as you can see in the picture, it led to severe surface melting, but it also led to rainfall. No snowfall, but rainfall. in winter in Antarctica, absolutely crazy. So how we can make sense of these extreme events occurring right now in Antarctica? Well, we need more data, and that is a big problem in Antarctica because, yeah, unfortunately, there are not a lot of observations available in Antarctica. Now, this is not a problem affecting Antarctica only. Unfortunately, we have, let's say, fewer observations in the whole southern hemisphere. So there is what we can call an interhemispherical data gap. So we have been, my group, have been working hard in order to, contribute to closing this interhemispherical data gap, and we have been trying to do so by setting a long transect nodes of about 4,000 kilometers, a small network of ground-based atmospheric observatories. So our northernmost observatory is located right here on the Changnantor Plateau. This is in the Atacama Desert at about 5,000 meters above the sea level. 5,000 meters is a lot. It's higher than Mont Blanc, for example, in Europe. So this is a popular destination for other kind of observatories. Our observatories are atmospheric observatories, but you can see other universities also use this particular location for setting astronomical observatories. Now, our observatories are basically containers, and these containers are fitted with state-of-the-art instruments that allow us to detect changes in the atmospheric composition. At the very end, you have to remember climate change is occurring due to changes in the atmospheric composition. Our second station is relatively close to Santiago de Chile, the capital of our country. 40 kilometers east is also above the mountains, but it's not that high. It's only at 2,600 meters above the sea level. It's still relatively high. The snow that you can see in the plots, the picture, are seasonal snow. Actually, this is the same station, the same observatory in summer. Of course, our favorite station is that we operate attached to the Cordero station, belonging to the Chilean Antarctic Institute. This is at the northern tip of the Antarctic Peninsula on King George Island. Now, the instruments we have in Antarctica are more or less the same instruments we have in the other stations. I have unfortunately no time for describing what exactly we have, but it is true in Antarctica we are doing something extra. We are doing some things that we are not doing in other places. For example, in Antarctica we often launch weather balloons, and this is a highlight for our research, but also is a highlight for politicians that often visit Antarctica. For example, a couple of years ago, also in November, the United Nations Secretary General was visiting us, and of course he was taking a picture launching one of our balloons. Now, I cannot again explain what we exactly are measuring in Antarctica, but just let me underline the fact that we are contributing to quality control, open access, international networks. So the data are available to everybody, and the idea is not only supporting science, but also our decision makers. Now, my final message to you today is that we need more researchers. It's not only instruments that we need also more people. And I would say we need better people, better researchers. And we strongly believe in international cooperation. I mean, we believe international cooperation can really allow us to form that next better generation of polar researchers in Chile. So that is why, since we began to operate in Antarctica with the support of the Chilean Antarctic Institute, we have been trying to embed, to include in our teams, in our Chilean-led teams, young researchers and students from our international network of collaborators. So over the last year, I was just preparing this slide and just noted we have been including in our teams students and young researchers from 14 different countries, so we are very proud of that stuff. And I just want to underline what we are doing at this very moment. For example, in the last season, our students in Antarctica were making measurements related to studying surface melting. I already mentioned, very important. Atmospheric profiling, very important to better understand the atmospheric rivers that are related to most of the extreme events we have seen in Antarctica in recent years. We have been making some measurements related to UV extremes. Remember that I mentioned this old friend, the ozone hole. The ozone hole is still around, so we need to track the evolution of that problem we still have in our atmosphere. And we have been making also measurements of snow pollution. We published just a couple of months ago a paper in collaboration with Jorge, with Gino, and a lot of other colleagues related to the pollution footprint left behind in Antarctica by the booming tourist industry, and also the very energy intensive activities that we conduct in Antarctica when making measurements over there. Also in Antarctica, this is my last slide, we have been collecting in areas of blue ice, we have been collecting micrometeorites. Of course, this is a real picture, but the meteorite that you may be able in the slide is not real. I mean, I just Photoshop it for give you an idea how is the place. You see, micrometeorites, of course, are very small, micro in the size of micrometers, so you cannot see it by naked eye, but you know, yeah. I wanted to show you a picture of how at least the place we are looking, these micrometeorites looks like, okay? Thank you very much.
Thank you very much, Raúl, for your very illustrative presentation. And now I'm going to ask you if there is any question for the presenters. If I have one, I have a couple, two questions actually for whoever wants to step up. The first one is related to, well, to the ways how you as scientists think that you could better explain in spaces like these ones, like we are today, that science has really be the driver to feed the process and then to take climate policies according to what you are researching, what you are finding, the kind of research that you are conducting nowadays. And the second one is, according to your expertise, what could be the measures, the adaptation measures that the Chilean government should be taking or should be thinking to take in the coming future in order to respond cautiously to the effects that we are seeing now happening in Antarctica.
If I can take the first one, Cristóbal.
Okay, go ahead, Gino.
And I'll leave my colleagues to the adaptation, or maybe they want to comment on the first one as well. But it's extremely important for decision makers to base their decisions on real data, on robust data. So it is our responsibility as scientists to provide the best knowledge, the best information possible. And both Jorge and Raúl, and you also mentioned that in your talk about science. So this is the role of science, and we need to provide this information, as I said, to our decision makers. It's not a blind decision that they will be making, but on the other hand, we have to be quite careful with the precautionary concept of we have to be cautious. So the science will give us a lead on the how the events are proceeding, what are the trends, and it will give us several scenarios in the future, and with perhaps some probabilities of occurrence. So it will not be certain, it will not be 100%. We cannot foresee the future 100%. So that's where our decision makers have to act based on the precautionary concept. That is, take caution on the future, and if you don't act, if it will be much more costly, it will cost even human lives, and of course damage to infrastructure. So these are the two main ideas I want to bring forward. Thank you.
Thank you very much, Gino. The other day on a side event, I heard that the best adaptation measure is mitigation. So it is totally synchronized what you were just said. And how about the first question, if Jorge or Raúl wants to say something about that? Raúl.
Well, I can say something that, yeah, of course Chile cannot stop global warming alone. Of course Chile cannot stop the ice losses that we have seen in recent years in Antarctica. But of course Chile can contribute to at least provide, as Gino said, the best available information of what is the current situation in Antarctica and in part of South America. That's true. But Chile can also do something in the short term, which is trying to reduce the footprint of all activities in Antarctica. For example, we have plenty of bases in Chile, and most of them are operating by using fossil fuels. So burning fossil fuels for operating Antarctica, maybe we can do more to reduce our carbon footprint of our local activities in Antarctica. So that is something that can be done, and we need better research infrastructure in Antarctica. A modernization is required, and also is required to invest in efficiency in the use of energy. So that is something that we can do in the short term, and it's not going to stop the losses of ices that we have seen in Antarctica, but at least it's going to reduce a little bit. We are going to make our contribution to at least the contribution that we have to do if we operate in Antarctica. Okay, we have to reduce our carbon footprint in Antarctica, and that can be, I would say, Chile is something that is achievable for a country as Chile. It's a matter of political will.
Thank you, Raúl. And Jorge, I don't know if you want to say something.
Okay, yeah. As Gino indicated, I think that more data is very important in Antarctica and also everywhere. With data, you actually can make information. Useful information come from data, and we need to make an effort that the data that already exists now in Antarctica will be in the future. I think it's really important that the stations network that has been installed by the INACH is very important, but will need maintenance in the future. To deploy at the station, I think is very easy, probably. But maintaining the station in the long term, I think is very difficult. And you need money for that. That is one thing that governments need to understand, that they have to support science in Antarctica. If not, well, no data, no information. And the other thing that I want to say is that Antarctica now is some kind of a new concept, the tipping points. Yeah? Changes that in some point will be abrupt and not point of return. And that could happen in Antarctica. And so it is really important to have more data probably that we already are having today for capturing this tipping point in the near future.
Thank you very much, Jorge, for your remark. Just I would like to add that something that I've been thinking about when you're hearing your presentations is that in my case, and as a social scientist, I think that it's really important also to address this I could call them these translation gaps. So why it is that there are some strugglings between scientists trying to communicate their research, their data, or the lack of systematic observation in certain areas, and the incapacity, I would say, from certain political dimensions of responding accordingly, considering obviously the threat that we all as humanity, as planet, we are facing now. So I think that also that is really important to address from a social science perspective, that translation gap, that we are all witnesses of that. So without any other, I don't know if you have any other remark. If not, I would really want to thank you for your time, for your presentations, all very interesting. I let you know that obviously these are recorded, so we can access afterwards. These are on the website of the ICCI, which is in partnership with the Chilean government and the Iceland government. And we have a very important virtual participation of nearly 20 people. So we are glad of making this event hybrid. Okay. So thank you very much, Jorge. Thank you very much, Raúl, and thank you very much, Gino, for your presentations and for your time this Saturday.
Thank you, Cristóbal. I hope you don't melt in Belém do Pará, which must be quite warmer than in Punta Arenas.
Definitely very, very warm. Okay, take care, all of you. Bye-bye.
Bye-bye.
Ciao.
Ciao.